Hello YouTube, this is Eli the OBD Tech. I'm here back working on this 2002 Nissan Maxima, but this time with a different problem. Customer complained that the vehicle has a check engine light and also has a long cranking, but it does start, but it just cranks a long time. So I have the vehicle already hooked up with my scanner. We have two codes. It's a P0335 crank sensor / circuit and a P0725 engine speed signal. This P0725 is mostly due to this P0335, since the crank sensor is not sending a proper signal back to the computer. So basically this crank sensor is causing this it's either the crank sensor or probably even a problem with the engine harness, which is causing this long crank condition on this vehicle. So the next thing is it's to basically confirm this condition. So I'm going to start the engine and see if this, like you said, this customer complained that the vehicle has long crank. So let's see this. Right now, I'm going to point you to the cluster on this vehicle. So here we go, guys. There you go. The car did start. It did crank for a few seconds, but it did start. I'm going to turn it off and redo it again. There we go, guys. You see that long crank? It took at least several seconds for it to start, but it did start. So the next thing is to basically check the wiring diagram on this vehicle for this crankshaft sensor, and then perform some some voltage checks on the power feed, on the ground, and on the signal on this crank sensor. But right now I'm thinking that the problem is it is the crank sensor, since the sensor it is going faulty at times, because he told me that when the engine's cold it does start right away. It's just when the engine's hot and he drives it, this condition becomes worse. Alright guys, so we're back at the engine bay. I'm going to perform the voltage checks on the three wires. Basically the harness the harness connector to this crank sensor is a green connector. It's basically the fourth one to your right. So I already have my red wire already back probing the black wire, which is our ground wire, and I'm using the CJ4 scan tool, which is also a 2-channel scope. So our ground should basically read less than 100 millivolts or less than 0.1 volts. Right now it's showing 0.5, which is good, which is less than 0.1, or in other words less than 100 millivolts. So basically right now our ground is basically good. Now I'm gonna back probe the our power feed, which is red with green, and see if we have our 12 volts on the battery. Take you back to the voltage reading. It's 12.45, which is also good. So it means our sensor is getting a ground and a power feed. So now the next step is to basically check our signal wire, which is a white color wire, which is pin 2. I'm gonna back probe it. Pretty tough, with one hand. But currently our voltage is reading 0.03. This is with the car off. It's actually key on, engine off. So That's another key to perform these voltage. Make sure that your key is on, engine off. So the next thing is to basically crank the engine and watch our waveform. So I'm going to go to the signal channel. I'm gonna, I guess, leave it at 20 volts per division, and then on our division time, maybe choose, I guess 100 milliseconds is fine. So next thing is to just crank the engine and see, and just watch our waveform to see if this signal is getting lost, or is choppy, or is just it's just out of whack, so which is causing this engine to have a long crank condition. Alright guys, so currently our signal wire, which is back pro to the white wire, is currently reading 0.06 volts. So so I'm going to crank the engine and see if we have a signal or a square wave. So, since this signal is a digital signal, it's going to be a square wave. Alright guys, so here we go. I'm going to crank in and watch the scope. So there we go guys. There was, currently there's no waveform, which should be a square wave on this signal. Currently reading 0.6 volts, which is not good. It means that the computer's not receiving a signal. But as I was cranking the engine, we saw the voltage was actually around 0.4, 0.5. So I guess the next step, since we have no signal or a square wave, is to basically go back to the harness and do a bypass test, just to see if the signal integrity of this white wire back to the computer. So basically to check if there's shorts or opens on this white wire. So alright guys. Alright guys, so in order to perform this bypass test that I was talking about, we need to first know the circuit design on this circuit, to see if this circuit is a pull down or a pull up design. In other words, right now, since our voltage is showing 0.06, this is with key on, engine off, it's showing 0.06 volts. Right now it's stuck low, basically almost 0 volts. Alright, and so in other words, by doing this bypass test, and to see if this is a pull up or pull out design, it's as simple as unplugging the harness connector. If this voltage goes high when unplugging it, this circuit is basically a pull down design. But if this voltage remains low, basically stuck at 0 volts, this circuit is a pull up design. So right now it's our voltage is stuck at 0.06. So I'm going to unplug the connector, and let's just watch our voltage. Remember, this is key on, engine off. Alright guys, so so this is with the connector unplugged. I already unplugged it. Our voltage remained at basically 0.06 volts, which means this is a pull-up design. And I'm pretty sure this voltage is probably around either around 12 volts maybe. This square wave should be around 12 volts. So a 0 to 12 volt signal. But since we didn't have a no square wave and no signal, we couldn't see the voltage on this signal. But I'm pretty sure on these Nissans, the voltage is from 0 to 12 volt signal. Basically a square wave, which goes from 0 to 12. Alright guys, so this, like I said, we have already confirmed this is a pull-up design. So the next step is to perform this bypass test just to confirm that there is no opens or shorts on this signal wire, which is a white wire. So I'm gonna hook up my test light and then show you guys. Alright guys, so to perform this bypass test, like I said, we confirmed that our circuit is a pull-up design. So I have my test light, which is right here, connected to battery positive post. And the reason I'm doing it is because, like I said, this is a pull-up design. So on a pull-up design, a bypass test, the test light should always go to positive post. When it's a pull-down design, to perform a bypass test, it should always be connected to the negative post. So always make sure when performing a bypass test to basically confirm if it's a pull-up or pull-down design, because that's going to determine where the test light is connected to. So in this case, it's going to be battery positive. So the next step is to basically touch this signal wire and see if we could drive this 0 volt condition to 12 volts, to basically 12 volts or more, which is going to basically tell us that the signal integrity from the connector to the computer, it's in good conditions, basically no shorts or opens. But if this test light, once I touch the pin on this back probing on this white wire, if this test light actually lights up, it means that there's a problem. It means this signal wire is shorted out to ground. So so I'm gonna perform this bypass test and see what happens, guys. So so I'm gonna first check my test light to battery negative to see if it lights. There you go, the light is lit. So so I'm gonna go back to the harness. Remember, this test should be with the key on, engine off. Here we go, guys. So so I'm gonna hit the back probe pin on this red lead right here. So, and let's watch this test light. This is not good, guys. So like I said, if this test light lit by touching this white wire, it means that we do have a problem. We have an electrical problem. This is we have a short to ground on the signal wire, which is causing this this 0 volt condition all the time. Like I said, we didn't have no square wave, while we were cranking the engine. So pretty much, this diagnosis is coming down to a harness problem, a short to ground in this white wire. All right, so the next thing I'm going to show you guys is an example on the camshaft sensor. This vehicle has 2 camshafts, one on bank 1 and one on bank 2. So, so I'm going to show you all these tests on a good working circuit. So basically on the camshaft, this camshaft and the crankshaft are pretty much the same circuit design. It's a pull-up design, and is also a digital square wave. So all right, so I'm gonna set up and then show you guys. All right, guys, so I have the camshaft back probe. This is a camshaft sensor. It's on bank 2, which is in front of the vehicle, next to the radiator side, which is right here. This is our bank 2 camshaft sensor. Sorry, back probe. Our signal wire is our middle wire. It's also a white. It's also a white wire. So right now I have back probed, and it's currently reading. This is with the key on, engine on. It's reading 10.66 volts, which is pretty good. So the next step I'm going to do is basically disconnect this connector from the sensor, and basically watch this signal that's right now 10.66 drop to basically 0 volts, which is, like I said, this is a pull-up design. So by unplugging it, this voltage should drop to basically almost 0 volts. All right, so I'm gonna unplug it and just watch this signal drop. And this is basically a good working circuit by performing this test. So here we go, guys. So as you can see, our voltage basically went to 0.08 volts, 80 millivolts. So this basically confirms this is a pull-up design. This is on a camshaft. Like I said, this camshaft and crankshaft circuits are pretty much the same. the sensors are pretty much the same part number. So like I said, I unplugged the connector, which is right here. So this is what the connector unplugged from the camshaft sensor bank 2, and our voltage basically is showing 0.08. I'm gonna plug it back in and watch this voltage go back to basically 10 point something. So here we go, guys. The voltage went back to 10.66 volts. So it's, so this is a good working design circuit. So now, I'm gonna perform the bypass test now with the test light. But to perform this test, like I said, this connector must be unplugged. So so I'm gonna unplug it again and then perform this bypass test with the test light connected to battery positive. Pretty tough with one hand. So here you go. The connector's unplugged, went back to 0 volts, pretty much. So now I'm gonna touch this this signal wire, which is our middle wire, our white wire, and basically drive this 0 volts, which is right now with the connector unplugged from the sensor. Basically watch this 0 volts go back to, I guess, battery voltage. Since our test light's connected to the positive post, this signal wire should get pulled up to battery voltage. So here we go, guys. So I'm gonna touch this, like I said, this signal wire with the test light, and this signal should go high. So here you go, guys. So as you can see, our voltage is 12.44, which is basically battery voltage. So this is a way to actually check the signal integrity. Like I said, this is a good working circuit. This is our bank 2 camshaft sensor circuit, and this is how our crankshaft sensor circuit should have performed. But with these voltage checks and this bypass test. So I'm gonna release it. So it went back to 0 volts. I'm gonna touch it again. It went back to 12 volts. Like I said, it's a pull-up design. So this is basically confirming that this circuit has no opens or shorts, and we confirming our crankshaft circuit that we do have a short circuit. So I guess the next step is to basically diagnose this short circuit and follow this white wire and see where this white wire is touching ground. Alright guys, so I decided to show you guys a square wave on bank 2 camshaft sensor. This is basically the square wave, a good working circuit, and this is the basically the characteristics on this camshaft square wave. Basically skinny square waves. But on our crankshaft sensor square waves, those are a bit different. Those should be much thicker than these. So so this is just a reference square wave on this camshaft. Alright guys, I believe that I found the short to ground. The problem lies within this engine cover, because when I was about to actually begin to unscrew these bolts, 4 bolts on this engine cover, which is 1, 2, 3, and where's number 4? Right here. I saw that my signal wire on the on my scope actually jumped to 10.66 volts. So I'm gonna actually show you guys this symptom that I was actually doing. I'm gonna basically make this bolt loose, and basically I'm gonna show you guys the square wave. As the more I make this bolt loose, our voltage jump to 10.81 volts. So basically our problem lies within this engine cover. this cover is causing this short to ground on the signal wire on this crankshaft sensor. Like I said, right now our crankshaft showing 10.81 volts. So I guess the next step is to basically turn the car on and let's watch this square wave. Alright guys, you know, so this is moment of truth. I'm gonna crank the engine and let's basically see if this crank becomes a long crank or if this crank becomes a short crank, which basically, if it starts up real quick, it means that we have solved the problem. The problem was basically that signal was shorting out somewhere beneath the engine cover. So here we go, guys. So here we go. As you can see, the car started real quick. And, you know, so this crank was not a long crank, it was a quick crank, which is we basically have confirmed the fix. The problem was a short to ground beneath the engine cover, which basically, you know, the engine cover was causing this short to ground on the signal wire. Alright guys, you know, so I'm going to show you guys the square wave on this crankshaft. Alright guys, so this is the square wave on this crankshaft. I had a back probe right there. So, you know, so the characteristics are almost similar to the camshaft, but you can see that the square waves are more they're evenly spaced compared to the camshaft signals. So I'm going to do right now is basically show you a camshaft comparison to the crankshaft by basically scoping both sensors at the same time. Alright guys, you know, so I'm going to set up and then show you guys. Alright guys, so I'm here showing you guys the comparison between the crankshaft and the camshaft square waves. Channel 1, which is the top one, that's our crankshaft sensor signal, and channel 2, which is our camshaft sensor signal, which is square wave. I was wrong within the characteristics of the crankshaft. I said earlier that the crankshaft square waves were thicker than the camshafts. It's actually the opposite. The camshaft square waves are actually much thicker than the crankshaft square waves. So this is how the correlation of a camshaft and crankshaft square waves basically look like. Alright guys, you know, so I'm just showing you guys the short to ground location, which was basically below the engine cover. This right here was getting pinched, so this was basically causing this short to ground. I don't see any type of insulation damage here. Oh yeah, I do see it right there. You know, it's tough to grasp the little area which is right here by my thumb. You know, I can't really give you a good view, but if you guys can see it, it's about right there. A little rip was causing that short to ground the signal wire. So just right, basically, I don't know, my camera could pick it up, but it's about right there, guys. That's where it was getting shorted to ground on this engine cover bolt right here on the base. So you know, so this is the final fix. So hopefully this video was entertaining, and hopefully my methods of diagnosing you know, helps anyone out there. Alright guys, thanks for watching. Subscribe if you like.